Hey there, it's Jason Gorman from Codemanship with another video diary entry. Before I get talking on today's topic, if you've been enjoying these videos, please like and subscribe to this channel and ring the bell for notifications. Thank you very much. Okay, so I want to talk a little bit about, the topic, the headline topic for this particular video diary entry is this notion of statefulness or statelessness in our logic. But it touches on a wider topic, which is a reluctance or an inability, I think, of a lot of development teams to consider logic at the system level. And I think this has grown over time, over the years. I've seen as teams start to sort of specialize more and more between sort of front-end browser-based development and server-side development and database development and web services and all that kind of stuff. We have a tendency to only see our piece of the jigsaw, our piece of the puzzle, if you like, and not to consider the whole picture. And this idea of statelessness in logic sort of plays into that, I think. And I wanted to illustrate that with a very simple a JavaScript example, a little bit of functional programming, if you like. So I've got a couple of functions here that manage transactions against a bank account. And these are what we would call pure stateless functions in the sense that their outputs are entirely determined by their inputs. So they don't remember anything. They're not accessing a database of account histories or anything like that. We give it a bank account with a balance. It changes the balance and returns a copy of that bank account. So you would say that it's purely functional. It's stateless. It's standalone, if you like. There's no history involved. And that's really what we mean when we say stateful. We mean that there is a history, for example, of function calls or a history of interactions with an object. And the behavior changes depending on that history. So we have to take into account the history of the bank account and all of its transactions. So a lot of developers would say to me, oh, Jason, our code, we write functional code and all our functions are stateless, or we create stateless web services, or so on and so forth, or microservices. And at the component level, that may be true. At the level of these functions, it is true, they are stateless. Their outputs depend entirely on their inputs. There's no concept of a history of calls to either of these functions. But I've got a test that's failing at the moment. We're going to take a look at this test for our bank account, where I execute a sequence of transactions. I credit some money, debit, and so on and so forth. And then I check at the end that the balance is what we would expect it to be. And this test is failing because the balance is what it originally was. It's the original account balance. And that's because I need to take the bank account that's returned and feed that in to the next interaction with those functions. So I'm creating a history here, essentially, to make these tests pass. So now the account has, essentially it has a history. So if we rerun those tests, that should pass now. Because we're actually remembering, if you like, on the client side, we're remembering the state of the account. And that's the point I wanted to make. Yes, at the level of the individual functions, or you might say at the level of individual components or individual services, yes, it may well be stateless. But at the system level, something somewhere has to remember the history of that bank account. And we see that, for example, when we think about stateless protocols like HTTP, for example, is stateless. The web is stateless, they would say. But of course, the web is not stateless. When I use a web application like, for example, Google Maps, there's state everywhere. And it's being passed backwards, being managed by passing that state backwards and forwards in the web requests. So it is remembering what I've asked it to do. The session that and that's what we call them, web sessions, the history of interactions I've had with Google Maps in this session is being remembered somewhere, whether the state is being held on the client or it's being shipped back and forth, or it's being held on a database somewhere on the server side that manages session state. Something somewhere has to remember. And so it's kind of a nonsense at the system level to say, oh, our code is stateless. Maybe your code is stateless, but when we look at the complete system, it's very rare. I mean, we can think of some obvious examples, like your maths libraries for your programming language are usually stateless. They don't have any concept of history. The square root of 4 will always be 2, no matter how many times you ask for that square root. But those occasions are rare. Most applications are dealing with objects that have, or at least from the end user's point of view, objects that have persistent identity. That is, it's the same, Cambridge is the same Cambridge, regardless of what I do in my session. And the bank account is the same bank account. If we take a look at our bank account object in the tests, you'll see we're identifying it persistently as the same bank account, even though in the code it's a copy of that bank account. As far as persistent identity and history are concerned, it's the same bank account. As far as the user is concerned, it's the same bank account, and the balance is changing on that account. Even if we're performing some magic in our middle tier, for example, to make that not the case. So state has to be managed, whether it's in a database, whether it's passing data back and forward in web requests for session state, whether it's things like transactional memory, or more complex solutions like that in memory databases, or just plain old objects that hold state. State has to be managed somewhere. It has to be maintained. The history of that object has to be maintained. And so you do need to consider your systems as stateful. Even if parts of it, individual components, are stateless, the system as a whole is stateful. And this is where we get into difficulties, particularly when it comes to issues relating to concurrency. If you imagine that this bank account has multiple account holders, and they can put money in and take money out, etc., separately from each other, concurrently, if you like, you still have to manage the logic of that. You still have to manage for potential conflicts and so on and so forth. You still have to reconcile all the history of all those transactions, those concurrent transactions. So again, it's a bit of a myth, particularly in the world of functional programming, that functional programs are more reliable because they're stateless, and therefore they can do things concurrently, and there's no history. But at the system level, that's just not true. And what I tend to see happening with teams is they push those issues out onto other teams, basically, and say, we're not going to manage, we're not going to think about state, and we're not going to think about concurrency. We'll let you handle it. We'll let the database handle it, for example, or we'll use some kind of event sourcing solution where we'll just keep a history of all of those transactions, a history of all of those events, and reconcile it that way. But it's somebody somewhere has to think, or what happens if two people try to debit the same account at the same time, and there's not enough funds for both of them? Somebody somewhere has to think about that. Somewhere we have to have that logic at the system level. So this is really, I suppose, about user experience. User experiences are usually stateful, in the sense that the user believes that things that they've done are being remembered by the system. And it's very difficult to build any kind of computing system where that is not true. So you have to manage it somehow, and you have to manage it somewhere. And so you might think, well, we'll let the architect worry about that, or we'll let the database administrator worry about that. But we're all involved in defining that overall system level behavior, the overall user experience. And so we all need to think about it, and we all need to play our part. And I found over the years that it's actually easy. I like my state where I can see it, basically, in the same way that I like my dependencies where I can see them. So I don't think, well, I'll just use Spring, and that will manage my dependencies for me, my dependency injection for me. No, you still have to think about it. And I would rather have my dependencies where my compiler can see them. This is a thing about architecture generally. We often think about architecture as the boxes, on our boxes and arrows diagrams, but really architecture is mostly about the arrows. We need to think about how the components of our system are interacting with each other. There's a great notion in object-oriented software construction, the book by Bertrand Meyer, where he talks about it's not enough that the individual components of our system are correct. their interactions have to be correct for the system to be correct. And we need to be thinking at that level of interactions between components in the system. And that's where the idea of statelessness becomes something of a nonsense, because at the system level, there's usually no such thing. So we do need to think about it. That's not to say that you shouldn't be writing, if you're into functional programming, for example, you shouldn't be writing stateless functions. Or if you're into object-oriented programming, you shouldn't be making your objects immutable wherever possible. I'm not saying that. What I'm saying is you still have to think about state, and you still have to think about the history of your objects and the identity of your objects, and especially if you're dealing with concurrent access to objects. Even if they're copies of the same object, logically at the system level, they are the same object. They're the same persistent object. So there you go. Statelessness, it's a localized concept. It's at the system level, it's a myth. In most cases, people talk about the web being stateless. It is, of course, not stateless. We've had to find ways to get around that, to make it stateful, so that we can actually build applications that work. Anyway, there you go. That's today's video diary entry. So, I hope you're doing well. Things are getting a little scary here in London, but I've got my fingers crossed. I'm hoping for the best, but we should be planning for the worst. So we may be locked down soon, in which case there'll probably be a lot of video diary entries. But otherwise, stay safe until the next time.